Hello, third graders. It is Monday. What is it? April 27th, I believe. And this is the Unit 5 review for the Unit 5 test. We shortened up that unit. As I told you previously, there's only certain standards that we have to cover. So we're almost ready for the test. Please go to Schoology, upload this review that you see in Schoology to Notability, so that you can write on your document as I teach this to you. So here we go, the first one. Okay, it says a park ranger has 32 feet of fencing to fence 4 sides of a rectangular recycling site. What is the greatest area of the recycling site that the ranger can fence? Explain how you know. So thinking back to what we learned, we said if a certain area is kind of long and skinny, it's going to be a small number. But whatever you can come up with that's closer to a square, that's going to have the largest area. And that's what they say we want. We want the largest recycling site possible. So we have to figure out what shape could this be so that the perimeter is 32. So we need the perimeter to equal 32. So if we add up all these sides, it has to equal 32. Also keep in mind that a square can be called a rectangle. So if I say 32 divided by 4, because a square has 4 sides, that equals 8. So we can say that this square, each side equals 8. And let's make sure that's right. Let's say 8 plus 8 plus 8 plus 8. Well, 8 plus 8 is 16. 8 plus 8 is 16. And if you add up those 16s, that equals 32. So now we know that this is, in fact, the correct shape and the correct area for the recycling site. The question now asks us, what is the area? And the area is length times width equals area. And let's look at the two sides. We have an 8 here and we have an 8 here. So 8 times 8 equals 64. And then it also talks about how do you know? Explain how you know. And you could say something like this. I know a shape that is close to a square, or is a square, has a big or greatest area. Okay, so that's how we know. All right, we're going to go to the next one, which is this one, about Steve. Steve made a banner with an area of 8 square feet. On the grid, draw all the possible rectangles with an area of 8 square feet, whose side lengths are whole feet. So all they're saying here is no fractions and no decimal points. Label the lengths of 2 adjacent sides of each rectangle. And adjacent means if you have a rectangle, this side here is adjacent to that side here because they meet in the corner. Label each rectangle with its perimeter. So on a sheet of paper, or you can just use the side of this, you need to come up with a shape. So we need to come up with a banner that has an area of 8 square feet. So one banner, I'm going to use this space over here, could be in 1 by 8. So banner is like a long sign. So 1 times 8 equals 8. So that would be one possible banner. Another possible banner could be a 2 and a 4 here, because 2 times 4 also equals 8. And it would be square feet on each of these. So then the question says to compare the perimeters of the banners, what do you notice about their shapes? So we could say that the banner with the greater perimeter is long and thin. So if we look at this banner, I'll make it a different color so we can see it better. Sorry about that noise, my iPad's making a squeak. So this banner right here would be 8 plus 8 plus 1 plus 1. And that perimeter would be, this would equal 16, this would equal 2. So that perimeter would be 18. So I'm going to put a P equal 18. And then if we look at, I'm going to move my book so it doesn't keep making that noise. And then if we added up the perimeter for this second one, it would be 2 plus 2 plus 4 plus 4. If you put the 2's together, you get a 4. Put the 4's together, you get an 8. And sorry about it being kind of messy there. 4 plus 8 equals 12. So clearly, when you compare these two banners, the banner that is green has the greater perimeter. Here's our next one. Mr. Gomez hangs a mural on the classroom wall. Find the perimeter and area of the mural. So when we're trying to find the perimeter, we count up all the sides. So 1, 2, 3, 4. If this side is 4, then this side also is 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. This side is 9. This side is also 9. When you add up 9 plus 9 and 4 plus 4, right here we're solving perimeter right now. 9 and 9 is 18. 4 plus 4 is 8. And then I'm going to turn my problem like this to add up. 8 plus 8 is 16. Carry the 1 into the tens place, 26. So the perimeter is 26 on this mural for the classroom. And then the next question is, what is the area of this mural hanging in the classroom? And we know area is length times width. So here's length times width. 4 times 9 is 36 square feet. Layana, I think is how you say it, plants a vegetable garden in two sections. She plants corn in a section that is 5 meters long and 6 meters wide. She plants squash in a section that is 3 meters long and 6 meters wide. Describe one way to find the area of the garden. Then find the area. So I'm going to make one big garden. Okay, I'm going to make sort of a big garden here. And I'm going to say that this side is the 6 and here's the 5. So in this section is the corn because it says it's 5 meters long, 6 meters wide. And then she also plants some squash. And this one is going to be 3 meters long and 6 meters wide. Okay, so one way to solve this is to say 6 times 5 in parentheses plus 3 times 6 in parentheses. And 6 times 5 is 30. Bring down the plus sign. Oops, I made the wrong sign right there, didn't I? I bet you guys noticed that, and I didn't till now. Okay, this is supposed to be a times. 3 times 6 is 18. So now 30 plus the 18 is 48. So the area is 48 square meters. Is this one in here twice? Find the area of the garden. Then it says to draw a picture of the garden to show your answer is correct. And I guess I already did that because I got the 48 and I had my picture. Okay, our next one already. is Lana plants a vegetable garden in 2 sections. She plants corn in a section, and in a section that is 5 meters long and 6 meters wide. She plants squash in a section that is 3 meters long and 6 meters wide. Why do I feel like I did this? Okay, this one's in here twice by mistake. This one we don't need to do. We don't need to do that one, but we do need to do this one. So on this one, the thermometer shows the temperature at 3 p.m. Okay, let's pay attention here because I see Celsius is on the left and Fahrenheit is on the right. And I think when we did this one when we looked at a thermometer in our math book on, I guess it would be Friday, they had it flipped. So let's just pay attention to what temperature does the thermometer show in degrees Fahrenheit. So we have to look at this side, and you can see where the red mark is, and I can see here's the 90, here's the 100, and if you look really carefully, here's the 90, here's the 100, and each of these little lines stands for 1 degree. So 91, 92, 93, 94, and I would say it is lined up with 95 degrees Fahrenheit. Let's put a label on that one. And the next one says, at 2 a.m., it is predicted that the temperature will be 16 degrees lower. What is the predicted temperature in degrees Fahrenheit at 2 a.m.? So now we have to do a little bit of math. So if it was 95 degrees at 3 p.m., but now 2 o'clock in the morning, it's 16 degrees cooler, we have to subtract. So 5 minus 6, we can't do that, so we go next door, make the 9 into an 8, make the 5 into a 15. 15 minus 6 is 9, 8 minus 1 is 7. So the answer for B is 79 degrees Fahrenheit. And here is our last math problem that we're going to work on for today. Oh no, I think we might have one more. It says draw a line from the figure to the area of the figure. So we're counting up each little box, or of course you can make this into a different math problem using these. You could figure out A, B, and you could figure out C, and then add those all up. So you could do area, or you can just count, which is what I'm going to do this time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I can draw a line to 15 square units. Your turn to solve the next two. Okay, and this is the last problem of the review. Ricky buys some tomatoes for $2.19. She pays with 3 $1 bills. How much change should she receive? So she's going to pay this much money, and she has 3 $1 bills. I'm going to change that color. So she has $3. So if she gives the cashier $2.19, what's her change going to be? Well, if we're at $2.19, if we put a penny with that, that'll bring us up to $2.20. Well, now that we're at $2.20, what if we put a nickel with that one? It'll get us all the way up to $2.25. And I know that we talked a lot about memorizing 25, 50, 75, $1. So let's go with a quarter, because now it's $2.50. And if you do another quarter, $2.75, and one last quarter gets us to $3. So now it's your job to count up the coins. 25, 50, 75. Now 5 more cents is 80. 1 penny is 81